Our second application is word problems. I know you're probably like, oh no, I do not like word problems. These are not too bad because we're literally either doing slope, if it says average rate of change, or we're doing the derivative, if it says instantaneous rate of change. The only other thing we could do besides these two things is just plug into the original. If it doesn't say the word change, we'll plug into the original. So let's look at our first example and we'll just keep calm. No change word, then we will plug into the original. Average change, we'll plug into the slope. Instantaneous change, we'll take the derivative and plug in. So for this first one, we have a chain pizza restaurant is installing pizza warmers into their fleet cars. The number of fleet cars with pizza ovens installed is given by this V of t. So we're going to use this equation either to plug in and just find a y value, plug in and find the slope, or use it to take the derivative. And then we just need to take note of our units. V of t is measured in thousands of vehicles. So my output is thousands of vehicles. And t is measured in years. There's my input. If I know the year, then I can figure out how many thousand vehicles we have. So I have my output and my input. And t equals 0 corresponds to 2012. So what's important about this when we do rates of change is that they always have two units. So let's make a note for all these word problems. If it is a rate of change, it's always, rates of change always have two units. It's the output over the input, right? If you got pulled over, you wouldn't say, but officer, I was only going 50 miles. You would say I was only going 50 miles per hour. So some examples of this could be miles per hour. It could be feet per second. But for this problem, my output is thousands of vehicles. It's 1,000 cars per my input is years. 1,000 vehicles, or just shorten it, say cars, and that's per year. So output over input anytime you find a rate of change. So just be aware of that. The first part says, what was the number of vehicles with pizza warmers in 2015? Do you see the word change? We want the number of vehicles with pizza warmers in 2015. Well, this measures the number of vehicles for any year you want to plug in. So no word change means you do not have to use the slope or the derivative. We're just going to plug in and find the y value. But before we find the y value, we need to figure out what is the t value for 2015. So 2012 is t equals 0, and this is where I want to encourage you to literally count on your fingers so you don't get it wrong. So if 0 is 2012, 1 is 2013, 2 is 2014, and 3 is 2015. So we are going to plug in t equals 3. So we're going to do v of 3 into the original equation. So we're going to do 0.7 times e to the 0.12 times 3. And you probably need that whole thing in parentheses, or you can multiply that out first. So we're going to do 0.7 times e to the 0.12 times 3, and what you should get is 1.0033, and it just keeps going on and on. So 3 years later, there's only one car with a pizza warmer, right? This is measuring the number of vehicles with pizza warmers. After 3 years, they only have one car still? No, keep in mind the units. It's thousands of vehicles per year. So this, because it's in thousands, I might actually multiply it out. If this was in billions, I probably wouldn't multiply it out because I'd get a crazy huge number. But when it's in thousands, it actually makes a little bit more sense to me to actually multiply it out by 1,000. Again, billions probably wouldn't multiply it out, but thousands, it seems doable for this. So move it over 1, 2, 3 decimal places. They have 1,003.3 cars. Well, you can't have 0.3 of a car, so it's assumed we'll measure to the whole vehicle. So 1,003 vehicles with pizza warmers. that's decent after 3 years of putting them in the car to have 1,000 vehicles with pizza warmers. We didn't get a crazy answer like 2 billion or something like that. So our next part is saying how fast is the number of vehicles with pizza warmers changing in the beginning of 2015. So they had 1,003 vehicles with pizza warmers. How many more are they expected to get? Is it going to be more or is it going to be less? They're going to take some out of the running. Let's see what happens in 2015. So is that change at an instant or is that an average rate of change? It says changing, so I know it's one or the other. It's instantaneous change or average rate of change. And it's changed in just 2015. So this is instant change, which means I'm going to use what? The slope or the derivative? Derivative. So for instant change, I need to use the derivative. So let's copy down that function again. So v of t, my original function, is 0.7 e to the 0.12 t. So this is one of our harder basic derivative rules. This is rule 6, always popping up. Comes up a lot in real life. It means I'm going to take the derivative of the power times e to the original power. So v prime of t, I'm going to keep my constant multiple, 0.7. It's not a product rule because there's not 2 t's in this. So I have 0.7, and then I'll take the derivative of the power, which is 0.12, times e to the original power. Derivative of the power, 0.12t is just 0.12. That's our mini rule. And then we have e to the original power. Something I could do here is I can multiply these constants together. If that makes it easier, you can definitely do that. 0.7 times 0.12 is 0.084 e to the 0.12t, and this will tell me the change for any instant, but I'm asked how fast is it changing in 2015, which we already said was t equals 3. So I'm going to do v prime of 3, and plugging into my calculator, I have 0.084 e to the 0.12 times 3. And this whole thing might need to be in parentheses depending on your calculator. And when you do that, you should get 0.120399967. It keeps going. So it's only expected to grow by 0.12 of a car in 2015? No, remember our units are in thousands. So I'm going to multiply it by 1,000 just because I think it makes more sense. So moving it over 3 decimal places, you get 120.4 cars, but you can't have 0.4 of a car, 0.3. So it's 120, and it's a rate of change, so I need to say how fast it's growing. It's 2 units. It's growing by 120 vehicles per year at that point. So we've started to pick up how many vehicles that they're putting pizza warmers in. So some important things to remember is you can multiply by your units if that makes more sense. I, again, would not do it if it was billions. If you're plugging into the original, it just has 1 unit. This is measuring thousands of vehicles. And then if you're plugging into a rate of change, it's always 2 units because we just found that they're increasing their number of vehicles by 120 vehicles per year in 2015.